Welcome to Midnight Coding. Today we will solve LeetCode problem 207 course schedule. This is a graph problem, but before we continue, please like this video as it will give you all the luck you need to land your dream job. And just as an extra measure, subscribe to the channel and I promise you will succeed in your endeavors. And also, it encourages me to keep making educational content like this. Now, let's follow our 5-step process. Now, let's understand the problem. So we are not given the number of courses and what they are, and we're given the output. So the reason why this is true is that to take course 1, we have to take course 0 first. So the ordering would be this. So this is pretty intuitive and easy to understand. But once we see the next example, we're gonna really understand what this problem is asking us. We are given the number of courses 2. So we have 1 and 0 and the same for this one. So the reason why this is not possible is that to take course 1, you gotta take course 0. And to take course 0, you gotta take course 1. So you can imagine that there's a cycle in this graph. So since there is a cycle, this is not possible. And that's basically what the question is asking us. Is this possible to schedule this? And the only condition that it's not possible is that if there's a cycle in this graph. So now let's come up with our own example. So in this case, the number of courses would be 4. To take course 8, we gotta take course 7. And to take course 7, we gotta take course 2 and 3. So the ordering would be possible. It would be 2, 3, 7, 8, where we take course 2, 3, 7, 8 in order, and this would be possible. However, this would not be possible if 3 was pointing to 2 and 2 was pointing to 8. Now what this means is that to take course 8, we gotta take 7. To take 7, we gotta take 2. However, to take 2, we gotta take 8. Now, this becomes not possible. With that in mind, let's think about how we can solve this. Since this is a graph problem, we can come up with a number of solutions. We have DFS and we have BFS. Depth first search, we can go to all the paths in depth and then we're gonna say, for example, when you get to 2, are we visiting any of the nodes again? We go from 8 to 7 to 2 and we're asking, does 2 point to 7 or does 2 point to 8? If it does, return false. If it not, continue. That's a possible solution in depth first search. In breadth first search, we can also do the same thing. We can go level by level and ask the same question and it will work. However, in this problem, we are going to use something called topological sort. Topological sort is a special graph algorithm that we use to detect cyclic graphs if there's a cycles in a graph or any sort of problem that has dependencies on each other, such as course scheduling. From what we saw earlier, like course A is dependent on course B and course B is dependent on course C. So this is a dependency problem. So we'll be using topological sort to solve this. So this is how we are going to use topological sort. We have our graph and then we have a variable called in degrees. So now let's think of what they are. So for example, at vertex 8 or node 8, we have an edge to vertex 7. So in our graph, we're going to say something like this. And for 7, we have 2 vertices, 2 and 3. So we're going to say, and so on. So that's how we're going to populate our graph. And in degrees is basically the count of how many incoming edges we have to a given node. So for example, 8 has 0 in degrees, meaning that there is no nodes that are coming to 8. However, for 7, there is 1. We have 8 coming to 7, and the same for 2 and 3. However, if there was another node, let's say 10, and if it was pointing to 2, we were gonna say that 2 has 2 in degrees. In topological sort, we have sources and we have sinks. Sources are basically all the nodes that have 0 in degrees, such as 8, and sinks are any nodes that have no outgoing edges, such as 2s and 3s. So topological sort starts with sources and ends with sinks. And now let's take a look at how this might work. I'm going to define a result variable and I'm going to take the source, which is 8, and I'm going to put it in my result variable. Now that I have taken 8, I'm going to take it out of my queue. So this would be a breadth first search algorithm, and we'll be using queues. Now that we've done that, 7 no longer have in degree of 1, it has 0. Now it becomes our source. And we're going to do the same thing. We're going to take out 7, and then now 2 has no longer an in degree of 1, it has 0, and it becomes the source. And the same with 3, then we know that we are finished with our loop because we have no sources left to iterate through. Now you can see that the length of our result is 4, which matches the initial number of courses that we've given in the first place. So this is how we're going to utilize topological sort to tackle this problem. Now let's start coding. So here's the solution to the problem in Go. For this problem, we'll be using topological sort. So let's define our variables. So we need to define graph and in degrees. And after that, we're going to have to initialize our graph and in degrees. So to define our graph, let's make this a map. Let's make a hash map. And our graph is going to have integer keys and array as values. And now let's define our in degrees. And our in degrees is just going to hold integers as values. Now we're going to have to initialize our in degrees. So to initialize our in degrees, we're going to have to make a key for each courses. So let's say index. And then at this index, our in degrees hash map is going to be initialized to 0 in the beginning. And then we can just loop over our prerequisite to fill in our graph and in degrees. So now we're going to have to initialize our graph and in degrees with the prerequisites input. So for prerequisite, in range prerequisite, and don't forget to add this for the index, but we don't care about the index right now. So the source and destination is that at index 1, it's going to be the source, because to take course 0, you got to take course 1. And the same for destination, it's going to be at index 0. Now we're going to have to populate our graph. To do that, we can just say the graph source, and we can just append the destination to this list. And then in degrees, we're going to have to update it as well. So it's going to be plus equals 1, because the source is going to contain the destination, and this destination has an incoming vertex, which is source. So we've got to update it by 1. Okay, now that we've done initializing and filling our graphs, then we're going to find the sources. So sources is going to be an array of integers. And to find the sources, remember in our drawing explanation, we've said that any vertex that has 0 incoming edge, they are the sources. So we're going to say for key in range in degrees. If the key in this in degree equals to 0, that means we found the source, so we can just append it to our sources. Alright, now that we've found the sources, we just gotta write a while loop and then iterate until we find all the course schedules. So we're gonna say for length of sources is greater than 0, we're gonna keep iterating through our sources array. So the current vertex that we're looking at is going to be at sources at index 0. And that means we're going to have to update our sources, and sources is going to be everything after this index. So we're basically just discarding the first index. After that, we're going to have to save our vertex in an array as well. So I'm going to call it for course schedule, and it's going to be an array. And after that, we can just say course schedule equals to append course schedule at vertex. So this will keep adding our schedule in order, so we can later on we can say if it's possible to schedule all the courses. And the last thing we got to do is we got to update the neighbors. So now that this vertex no longer exists in our sources, we're going to have to decrement all the neighbors in degrees. So we can say for neighbor in range graph at this vertex. We're going to say in degrees at this neighbor is going to be decremented by 1 because the source is no longer there anymore. And then we're going to say if the neighbor, if this equals to 0, meaning that there are no incoming edges to this node anymore, we're going to make this our source. Okay, looks like I've misspelled neighbor over here. I'm going to just fix it quickly. Okay, that's basically it for this solution. Now we just got to return if it's possible to schedule or not. And To do that, we can just return if the length of our course schedule array equals to the number of courses, and if it equals, that means it's possible to schedule, and if not, that means there's a cycle in this graph, and in that case we cannot schedule all these courses. So we're going to say return the length of course schedule, and we can say if it equals number of courses. Okay, now let's run it to see if it works. Okay, we're going to define the variable. Now let's submit it, and it works. And now let's jump into step number 5. So I hope you learned something new today. And step number 5 is that at the end of our interview, we're going to have to think about more edge cases and then how we can optimize our solution in a better way. However, on LeetCode, we note that we have passed all the test cases. In our actual interview, we would want to come up with different edge cases. And then we have to think about how we can optimize our solution so we can show our interviewer that we are thinking of optimizing our solution in a better way. However, for this problem, topological sort would be as optimal as it would get. So with that being said, I hope you learned something new today, and I'll see you guys soon.